Welcome to this lesson on density, one of the most fundamental properties in fluid mechanics. Density describes how tightly matter is packed within a given space. Understanding density is essential for explaining why objects float or sink, how fluids behave, and many other phenomena in physics and engineering. Density measures how much matter is packed into a given space. Think of it this way. If you have two boxes of the same size, but one feels much heavier than the other, the heavier box contains material with higher density. Density tells us about the concentration of mass within a specific volume. The formula for density is written as ρ equals mass divided by volume. Here, ρ, represented by the Greek letter, is the symbol for density. Mass, represented by m, is the amount of matter in an object measured in kilograms or grams. Volume, represented by v, is the space the object occupies measured in cubic meters or cubic centimeters. By dividing mass by volume, we determine how much mass exists per unit of volume. The standard international unit for density is kilograms per cubic meter. However, in many practical applications, especially in laboratories and everyday measurements, density is also expressed in grams per cubic centimeter or grams per milliliter. These units are equivalent for water-based measurements and are often more convenient for smaller objects. High density means more mass is packed into the same volume. Materials with high density feel heavy for their size. Low density means less mass occupies the same volume. Materials with low density feel light for their size. This difference in density explains why some materials sink while others float when placed in water or other fluids. Let's work through a simple example. Suppose we have an object with a mass of 500 grams and a volume of 250 cubic centimeters. Using our formula, density equals mass divided by volume, we calculate 500 grams divided by 250 cubic centimeters, which gives us a density of 2 grams per cubic centimeter. This calculation shows how straightforward it is to determine density when you know the mass and volume. Let's look at some common materials and their densities. Water has a density of 1.0 grams per cubic centimeter, which serves as a reference point. Ice has a slightly lower density of 0.92 grams per cubic centimeter, which is why ice floats on water. Iron has a much higher density of 7.87 grams per cubic centimeter. Gold, one of the densest common materials, has a density of 19.3 grams per cubic centimeter. These values help us understand and predict how different materials will behave in fluids. Let's review the key points. Density is defined as mass per unit volume. The formula is ρ equals mass divided by volume. Density tells us how tightly packed matter is within a given space. This property is essential in fluid mechanics for understanding buoyancy, fluid flow, and material behavior. Mastering the concept of density provides the foundation for understanding more complex topics in fluids and physics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.